Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to DIY Metal Router. This is, sorry, not Metal Router, but Metal Mill. I think we are on episode 4 on this. So this is episode 4. So we looked at the different. I'm uploading a video, video game tutorial 2 for today's video, and then tomorrow probably going to start uploading these DIY mill ones because I'm a little bit behind, but still doing a video every day. So we're going to go back and start working on this guy again. We do have a general layout here, so we're going to start looking at some of the rails that we do here. What did I end up doing for this as far as the height? Did I make it the same size as the form? So you can see. But yeah, the issue that I don't like, I mean, it's cool that it's tall, but I don't think it really needs to be that tall. I mean, you do need some stability here as far as rocking, but I think that BT40 power head, I think that's probably long enough. Oh, this is a big boy. This is the same one, but they just want more money for it. Still 6,000 RPM limit. Well, they want a lot of money for that one. Anyways, this is a 3 kilowatt, 4 horsepower, 3,000 to 6,000 RPM range. Oh, 3,000 to 6,000. So this is a BT44. BT44. Yeah, BT44. Okay, so this is cool. So it kind of shows you the different RPM range. So here's the different RPM range. BT41, BT42, BT43, BT44. They all are the same dimension. They all have the same axle head size, central height. I don't know what that is. I don't know if that's to the center. What does that mean? Anyways, speed 33,000, 5,000, 5,000, 6,000, 5,000, 6,000. Rising temperature within 25 degrees, blah, blah, blah. Here, okay, so this is what it has. Some bigger bearings in it. So I think that this would take, oh, it says, yes, waterproof. I don't know what that means, but that's cool, I guess. But that's going to be a $500 power head, it looks like. Versus this one. About another $60. Oh, so this is saying it's a drilling head. So this one's about $400. This is about $450. Okay, cool. And this is with a motor on it. So what is this? This is a 2.2. So what is that? A 4 horsepower? Yeah, but they don't need to be that big. Motors do not need to be that big. But it's attached to the end, and then having this, how do you even tighten things on there? Oh, and this is a different style, looks like. This is, whoa, this is a big guy. Oh, this got a crap ton of this is ER40, BT40, MT4. MT4 is like a lower class spindle. Triangular pulley, rib pulley, regular pulley, synchronous belt, V belt, or rib belt. Well, this is a 2 horsepower head. It's a 1 horsepower head. Huh. And as you see, ATC really expensive. 200 millimeter. Sorry, getting a little distracted. Okay, 200 millimeter. That should work if I wanted to do. That's pretty cheap. Man, it is extremely hot in here. I'm gonna have to open up either the window or turn on this fan here. Let's turn on the fan. Okay. Sorry about the fan. So let's look at this guy. Oh, it's got a 100 millimeter. Sorry about that noise. Whoa, $1,600. That's more like the price that I would be looking for a regular head. So this might be, is this free shipping? Oh, it's really, really close. Huh. 6,000. Less than 0.0003. So I mean, at this point, really, something like this might be way better than that power head. I just got to build something to hold it. And it's got, oh yeah, it's got the drawbar that goes in there and grabs that guy. Did it say maximum horsepower? So we might still look at this. I mean, for right now, we're going to look at that power head, but really, I'm just going to find the best deal. So this is 6,000, which is that other one only goes up to 6,000 anyways. But these are BT30s. BT30 is fine. I'm not against BT30. Here's another BT30. Oh, it's BT15, a small guy. Is that a motor? ISO 20. Strange. Is there a power head? Oh, that's the BT15. 65 millimeters, so it's about the same size as some of these other things here. So hopefully the fan is not super annoying. But yeah, this looks pretty interesting. And then some cheap BT30 collets, $40 for tool holder. Yeah. Anyways, so yeah, let's see. Ooh, these are big guys. These have dimensions. 5 bearings inside. 5,000, 6,000, sure. Good rigidity. I mean, either or. I mean, obviously, I would prefer not needing to use a pneumatic and just using, you know, some sort of drill, basically, to tighten this stuff. So that's why I'm kind of into that more. And then I like the BT40 here because it could basically handle more of the power that we put down on. Oh, here we go, full color. 358. Yeah, 358. And that's also not showing that. So let's go ahead and let's model that. Let's model this thing. So let me go ahead and grab this guy. Oops. This guy over here, my second screen. Let's call this power head. So this is a BT40 6000 RPM power head. Okay, and let's go ahead and model it. I mean, we've already kind of wasted quite a bit of time looking around, almost 10 minutes, but that's okay. So let's go ahead and model this as closely as we can. So this first part, so let's start from the bottom here. So this BT40. Let's see. Where's the OD for this? It does not show what the OD is on that. Why does it not do that? 1 second. I'm missing something here. Anyway, okay, so let's start from the middle then. Let's start from the middle and work our way up as we figure that out, as I email them about that. So rectangle. Okay, so let's say 100, so this is 132 millimeters, and this is 121 millimeters. Let's change this to millimeters because this drawing's in millimeters. It's just going to save us time and issues. Okay, and then let's go ahead and do both ways, two-sided or symmetrical, and that is it's not actually 250. Oh, we could just say it's 250. That's not exact. Man, these are really not very good drawings. They're missing a whole lot of information. That's okay. So let's say this guy, this is 250 millimeters, let's just say. Oops, 250, which is not, but let's just say it is. And then we have a whole bunch of things here that are not completely clear. Then we have the next part. Which is basically, let's say that this is the front, so I kind of figured out inductively what size this circle is by looking at one of the pieces here. So basically there's a small little square here that is 7 millimeters, and it is a square that is 5 millimeters tall and 14 millimeters wide. And then basically this circle goes in tangent to this line here. This is a little notch that's missing throughout the entire thing, pretty much all the way down. So, go ahead and do that. Okay, so now that guy is there, and then that guy, it doesn't even tell you. I mean, this is going to be really hard to draw. I need to almost ask them for the model, because I can't really draw off this because it's just missing so much stuff. For example, how big is this? Right? You know, how big is this piece? How big is this piece? I mean, I can go in and scale the drawing. Maybe I'll do that off. Oh, wow, I'll probably do that later. So let's just save this for right now. I'll do that later. But what we can do is we can make this guy to scale as far as, oh, not the front. It's going to be back. Let's do this. We need to at least do this. Okay, so basically we have the center. Oh, is this thing that long? What the heck? No. Where did you get 500 from? Oh, it did 250 both sides. That's why. I was like, something is not right here. There we go. Okay, redefine sketch plane. Okay, edit sketch. So now basically we're gonna just set up the bolt holes to kind of get an idea of how this thing is going to go together. All right, so now, oops, what the? So now this is 80, basically. And how far in is it? Are you going to even tell me how far in it is? Oh, 106. Okay. Oh, so I guess we could just do a square off the center. Let's just do a square off the center. Don't delete this. Let's just do a square off the center. So it's a 160 by 106. Okay. And now we create some holes. And these are Oh, is this the front side? Oh, so these are not threaded holes. These are just through holes. Right. So these are, it says 117 and 11. So the smaller one's 11. For some reason there's two sizes. I don't know why they would do that, but it's 11 millimeter hole, and it goes all the way through. So let's just say distance through all. Okay, so now there it is. So let's go ahead and go to sketches and hide a sketch and save it. And now that's a BT6000 RPM power hit. Okay, obviously it's missing a lot of stuff, but that's okay. So let's go ahead and look at some of the different carriages that we'd be able to, some different high wind rails. The biggest high wind rails that we'll be able to use. So let's go back to, let's just go here to this one and duplicate. And then let's back it out to 100%. Okay, and then let's go ahead and look at this again. Whoa. This one they want $400 plus 212. You want a lot of money for this power head. Okay, okay, so that looks good. Alright, so what kind of weight are we looking at for this already? Properties. What? About 60 pounds? This is cast iron though. Let's change that. Material. Metal. Cast iron. Now let's change it back 2 inches temporarily. And then let's look at properties. About 1,000 ounces divided by 16. Look at there, 62 pounds. Let's see if it says. It says 20 kilos, so that's 66 pounds. Is that what I came up with? 1,000 ounces, right? Wow. So yeah, it's basically almost exactly, it's almost exactly solid iron, as if it was solid iron. Cat's meowing randomly again. Okay, so let's go ahead and save this, and then now basically what we're going to look at is we're going to look at our rails. So let's look at some high wind rails, and then we're just going to go to one of these and look. Ooh, what is this? Because again, probably these high winds are most likely fake anyways, so, but we'll go with it anyways. Alright, so let's look here. Okay, so the idea obviously is that we need at least this separation here. So we need at least this separation. So that is 100, 160. Oh, so this drawing is better here. So the drawing here is better, so sort of. Some of it's cut off. Anyways, yeah, this has got 5 bearings in it. That's cool. Where's that other one? Oh, I think it was this one. Yeah. Okay, so this is 106 apart. So let's see what's the biggest so we can go here. So here's the Highwind rail list. So we're talking 106 apart. So obviously if we could almost get these two to almost touch, that would be really nice. Some big old rails. So obviously that's W. So the idea is that with W it'd be close, or basically W divided by 2. Yes, W divided by 2, or almost, yes, W divided by 2. Well, basically it would be W, so it's W divided by 2 here, and then W divided by 2 over there, and then that would kind of be in the center of those holes, and then we'll have like a plate where it goes on there. So W, and again that's 106. So you can see here these things get massive. .106, right? So it could be like that. They're almost touching. HGH 55 CA. HGH 55 CA. HGH 55 CA. I don't know if they're going to have something that big. They have an HGH. So let's see. What's the biggest they got? So this is an HGH 15. 15's too small. 15's the smallest. So they have a HGH 25. Let's see, HGH 25. They have 20. Okay, so here's a 25. Here's a 25. So they have 25. About 30. So they do have a 30. That's a big boy. HGH 30. That's a W. Oh, that's a W of 90. Oh, that's with the flap. So that's what it's got, an extra flap on it. The flap is just kind of going to extend the moment, so the flap doesn't really do much. This doesn't have a flap on it, though, does it? Oh, yeah, it does. It does have a flap on it. That's strange. I wonder why it's got a flap on it. Oh, because the rail's in the way? It's weird. Well, if that was the case, so basically this guy has a little flap on it, right? So if you look at here, it's got this flap. And the flap extends it out to 90 for a 30. For 30 CAs of 90. So it is pretty big with the flap, but obviously the flap's just going to kind of extend the moment on how it twists on here. But in this image, it doesn't have a flap, so it's really weird. So I wonder if it has a flap so this hole could be deeper, right? Because this rail's in the way. But that's a pretty beefy rail, probably. 30. It's got a rail with a rail of 28 millimeters. about an inch wide rail. Wow. That's a big rail. That is a big rail. I mean, we could go bigger. Let's see if we can even find anything like that. Oh. Okay, so $30 a set. So now we're looking at something that is uh, 22 inches. 22 inches. About 600. Ooh. Oh, we could round it down if we need to do 550. 272. A two-piece. Oh, that's a pretty good deal. Right, so what does it say down here? Okay, so these are big boys. These are big boys. 30CA. So this is W60. So 30 here and 60 on the other side. So they're separated. They got a little bit between. And these are probably got big moment. So I don't know. It doesn't show. But kilonewtons. So these are like 3 times stronger than the standard. I don't know why it has 2 numbers. Very strange. And it's cut off. Oh, these are moments over here. Huh. Wow, look at the size of this one. These are too big. 106 is like this one. It's 55. So let's see, they have a 35. 35 is good price. I mean, 30 is good price. About 35. Okay. Whoa, huge bump in cost. Huge bump. Oh, this is 4,000, so that's like 12 feet. That's why. Let's see here. Okay, so here's 500, so that's 6. It's about the same price as the other one. That's a pretty good deal. So let's see, 550 millimeter. 550 millimeter. See if they have it. No, they don't. So I would have to cut it or drop the size to 500, but we'll probably even need more than that. But still free shipping, and these are big boys. Got some big old rails on it. And here's all the moment stuff. What should it show? Oh, here we go. MP is that way, rock back and forth. MP. Kind of doing some window shopping now. MP, so this is going to be a big number. So we're looking at these are what, 35s now? 35. 35. MP. HA is obviously more because it's longer. So it's 0.81. That's massive. And you're talking about 4 of those. So it's that each. So that's almost 3.2 kilonewtons per meter. And it's got plenty of resistance. And obviously I'm just making this thing as, as rigid as possible because there's not really much difference in the cost, it seems. So I'm just kind of see what we have to work with. So right now we're at 35, we're at 70. Let's see if we can find a 45. Okay. Yeah, so it looks like that's... Oh, they do have it. Oh, here we go. This is probably a small little guy. But look at the size of that thing. So yeah, I think we're going to start to struggle to find them now. CR. Yeah, so it looks like the 35 is probably the biggest that we're gonna get. And let's look one more time, because we're coming up here on time. Actually, we are on time here. So let's look at here. So now, here. So now, of course, we don't want these. We want it to be center and then be center here. So this is 160. So basically, we're looking at, we don't want the whole distance, 1 times the whole distance, which is half of that center distance plus half of that center distance. You know, it'd be okay if they touch, because that will give us the most moment, and obviously it's going to go down to here, because we don't need to clear this above the table. Obviously this nose is going to hit before the bottom hits, so that's not a problem. And that's okay if we, I mean, it's okay. What I would like to do is I would like to go up to here and then up to here. So it's even okay if we have it kind of biased a little bit and almost take up this entire area with rail. And then I'm not worried about it, you know, having issues. But then we don't have to make it as big as that Tormach. We could have less travel and still do the same amount. So let's look at that one. Where'd it go? This one? This one. Okay, so again, it's this one here. So let's look at this one. So it's 160. That goes, 160 center to center. So that's L divided by, well, yeah, L divided by 2. 35. And there's 2 different types. There's the CA and HA. L divided by 2 is a little bit under 60. Well, full L is 112, right? So it's this half plus this other half, so they don't bump into each other. So 35 HA is really close. Then we get higher moments. Interesting. So we might do that. And then L, so L is almost 140 millimeters. It's almost 5 inches. That is a big block. That's almost entirely block. So let's see if they have that really quick. So let's look at an HA. Let's see if they have it. Okay, so there's an HA. This is, how long is this? Oh, 200. Looking for 550, so. Because what I could also do is I could buy the rail and basically slide these on there, but they're really sketchy to get them to put them on without breaking them, and then you're out, you know, almost $100. These are $50 a piece, but then again, these things are massive. Okay, so let's go on the Trello. Green Machine Mill, and then we're going to say we're going to use HGH 35HA rails and carriages, and use HGH 35 CR rails using the BT40 6000 RPM 3 horsepower power head. Alright, that's pretty much it. So we figured that out. Alright, so this has been Steven from Legit Tech Tutorials and the Green Engineers. Thank you guys for watching. I'll catch you guys next video. Take it easy. Peace.